Alright, for this section, we are solving for sides of special right triangles. We have two types of special right triangles. One of them is a triangle with angles 45, 45, and 90. And then the other one is a triangle with 30, 60, and 90 for angles. So the first ones we're doing is the 45, 45, 90 because they're easier. The reason they're easier is that since I have two angles that are equal, two of my sides are going to be equal. And so we always use the letter S to represent the side length of the shortest side. And then the hypotenuse is always going to be given by the side length of the shortest side times the square root of 2. So it's just S square root of 2. So to solve these problems, we always create a table with the formulas in it. And so the formulas for a side with 45 across from a 45-degree angle is S. So this one has two sides that are equal. I know that they must be 45, 45, 90. So this is 45, this one's 45. So I always look at the side opposite from the angle. So this is 1 degree, that's 45. Opposite from that 45-degree angle, I have side S. So that's S. The other 45 also opposite from that is S. And then the hypotenuse opposite from the 90-degree angle, which is a little square, opposite from the 90-degree angle, it's S square root of 2. So anytime you have a triangle that's 45, 45, 90, you're always going to use this table. It's going to stay exactly the same. The only thing that is going to change is the bottom row, because that depends on the picture that they're giving you, the side lengths of each of the triangles that they're giving you. So for example 1, this is one of the easiest ones. We're going to do an easy one first, and then we'll move on to ones that are a little bit harder. But for this one, I'm going to fill in the bottom row using the picture that they're giving me. So I have a 45-degree angle down here. So opposite from that 45-degree angle, I have side with a length of 3. So below one of those 45, it doesn't matter which one, I'm going to put the 3. I have another 45-degree angle up here. So if I look opposite from that angle, there's an X. So I'm going to put that here. Again, those two could be flipped since they're both 45, so it doesn't matter. And then across from the 90-degree angle, I have that Y. So Y goes here below the 90. So now that I have my table, I can create 3 different equations. Those equations are always created with the bottom 2 rows. So I'm going to circle them. This is one equation, S equals 3. This is my second equation, S equals X. And then this is my third equation, S squared root of 2 equals Y. So I just take those 2 bottom rows, put an equal sign between them. This one's pretty easy because I always want to find the value of S. Here I have the value of S. It's already by itself, S equals 3, so I don't have to do anything. All I have to do is take that 3 and plug it into my other 2 equations so that I can find the value of X and Y. So I'm gonna just write that right here. I'm gonna plug in 3 for every S. So here S is 3, and that's it. X is also 3. And then right here, S is 3. I replaced it. Square root of 2 was part of my equation, and that's it. That's my Y. Can't do anything. Remember, I cannot multiply 3 with the square root of 2. I cannot multiply those two numbers because the square root of 2 is inside the square root, or the 2 is inside the square root and the 3 is outside. So it just stays like that. So that's it, that's my answer. This was very easy because I already had the S value. All I had to do was plug into my other 2. So let's see another one. Here I have across from 45, I have a Y. I'm going to put that here. Across from the other 45, I have an X. that goes there. And the last one across from the 90-degree angle, that's an 8 square root of 2. So that goes here. So one more time, I'm going to create my 3 equations. So this is one equation, s equals y. Second equation, s equals x. And third equation, s squared root of 2 equals 8 square root of 2. And so now I'm going to start with this equation. The reason I'm starting with this equation is because it's the only equation in which I only have the letter s. Here I have s and y, so I cannot solve it. Here I have s and x, so I cannot solve it. Here I only have s. Problem here is that s is not by itself, so I'm going to have to solve for s, solve for the value of s, so that I can plug it into my other two. So I'm going to solve for this equation. S is not by itself because there's the square root of 2 next to it, so I got to get rid of that square root of 2. And so there's no plus or minus sign, that means I'm multiplying, so opposite of multiplication is division. I'm going to divide by the square root of 2 so that it cancels out on the left side. And remember, whatever you do on one side, you do to the other side. So I'm going to divide by square root of 2, and it cancels out on the right side as well. And so now I have my s value. My s value is 8. So now I'm going to plug in 8 for every s value. So over here, instead of an s, I have an 8. That's my y value. I'm done. Over here, I have an s, so I'm going to plug in 8 one more time. And so that's also my x value, and I'm done. Makes sense because remember, 2 sides are always equal. Those 2 sides are each 8. Okay, so those were pretty easy because I had s as nice whole number, so it becomes really easy when I gotta plug it into the other 2. So now let's look at example 3. So here's example 3. And so again, it's a 45, 45, 90, so I have my table set up. I'm just going to fill in that bottom row. So here I have across from 45, this one, I have an x, so I'm going to put that here. Across from the other 45, I have 3 square root of 2. And then last one's y. Across from the 90, I have that y. So 3 equations, one more time. S equals x, that's one equation. S equals 3 square root of 2. And then the last one, s square root of 2 equals y. And so this time I'm going to start with the middle equation because it's the one where I only have s. Right here I have 2 letters, here I have 2 different letters, here I only have s. But here s is already by itself, there's nothing around the s. So all I have to do is take this and plug it into my other 2 equations. It's a little bit different just because now I don't have a nice whole number for my s, now I have a radical. So I'm going to have to plug in 3 square root of 2. So plug in the entire thing, 3 square root of 2. So when I plug it in on the first equation right here on the left side, I have 3 square root of 2. And that's it, because the s is also my x value. So I am done with x. When I plug it in over here, I'm going to have to still multiply. So I'm going to replace the s with the 3 square root of 2. So that s becomes 3 square root of 2 I'm going to copy the rest of my equation, so I still have a square root of 2 next to it, so that has to stay there. And then equals y. So equals y. So now I have to multiply this 2. Remember, I can only multiply numbers with each other if they're outside of the square root. So the 3, I'm going to multiply it with 1, because even though you can't see it, there's a 1 right there. So 3 times 1 is going to give me 3. And now I can multiply the square roots. The square root of 2 times another square root of 2 is just going to give me 2. If you remember, I'm going to do a side note over here. Square root of 2, when I multiply it twice, I can write it with an exponent of 2. And so remember, square root and square are inverse operations, so they cancel each other, and it's just 2. So here I just have 2. So now I just multiply those 2. 3 times 2 gives me 6. So my y value is 6. And then the last one, example 4. Here I have another 45, 45, 90. Across from 45 I have a y. Across from the other 45 I have an x. And across the 90-degree angle I have an 8. So one more time, I'm going to set up my 3 equations. S equals y, s equals 6, and s square root of 2 equals 8. And so now I'm going to solve for the last one, because here's where I have s as the only letter. And it is not by itself, because right next to it is the square root of 2. So I'm going to take the square root of 2 and I'm going to divide it so it can cancel out, and I'm going to do it to both sides. So now I have s equals 8 over the square root of 2. But there's a problem with this. I cannot leave this as my s, because I can never have a square root on the bottom. And so when that happens, I gotta get rid of that by rationalizing the denominator. So that's when I take that square root and I multiply that on the top and on the bottom of my fraction. So now I'm going to multiply the 2 numbers on top, my 2 numerators. 8 times the square root of 2, it is not 16. Remember, 2 is inside the square root, 8 is outside, so I cannot multiply them. I just keep them together. When I multiply the square root of 2 times the square root of 2, remember that just gives me 2. So on the bottom I have 2. And so now I can just simplify. Right here, 8 divided by 2, those 2 numbers are outside the square root, so I can divide them. 8 divided by 2 is 4. And that square root of 2 right there, it stays. You cannot forget that. So this is my s value. I'm going to plug in 4 square root of 2 for every s. So when I do that, it becomes really easy on this problem, because x and y are both s. So 4 square root of 2 is y, and 4 square root of 2 is also x. So that's it. I'm done.